Good evening, or should I say good afternoon? It's almost summer now, so the sun sets a little bit late. It's a pleasure to welcome you to this very, very exciting Future Talk webinar series where we're talking about the role of educators in building tomorrow's innovators through coding and robotics. You may ask, what do we mean by educators? Because, very often parents and communities are also educators. So this webinar is not just for teachers, even though a lot of what is going to be presented is particularly targeting at teachers. But it is important for parents as well as guardians to know what role they can play in supporting their children when they come back home, especially when it comes to coding and robotics. And to help us navigate this topic and demystify it or maybe make it accessible to all of us is none other than Poliswa Mahlangu. Poliswa Mahlangu is the head of our digital learning at Sifiso Learning Group, which includes Sifiso EdTech as well as Future Nation Schools and Future Nation College, which is a teacher college that we've now started. And we're going to be taken through a journey of what is involved in coding and robotics, how educators, particularly in the classroom, may navigate the process of how you build tomorrow's innovators through coding and robotics. Because the exciting thing about coding and robotics is that it is a lot of fun for young people to code, to build structures using robotics kits. And you can actually teach a lot of principles, including mathematical or geometric principles. You can teach creative arts. You can teach counting, in other words, numeracy through coding and robotics. At the same time, you can teach coding languages that are used for building applications and a lot of other things that we use in our everyday lives. So to help us through this, as I indicated, is Ma'am Poliswa Mahlangu, who's going to take us through this whole world of coding and robotics, which is very exciting. And it's particularly exciting, and I must thank the Department of Basic Education, because with effect from the 7th of June this year, 2024, coding and robotics has now been gazetted or promulgated as a subject which is offered at schools. And as FISO EdTech, we have been supporting the rollout of coding and robotics, particularly in public schools, in a lot of far outlying areas and rural areas and so on, where we work with a lot of our partners, corporate partners, foundations, and NGOs to support the Department of Basic Education in the rollout of coding and robotics in our country. Because the 21st century is well upon us, the fourth industrial revolution, or even the fifth industrial revolution is upon us. So it is important for us as a people, as a nation, to prepare our young people for the future world of work. So it is important that we talk about this issue of coding and robotics and how it can be used to build innovators of the future, to build entrepreneurs, to build people who are going to be creating things. Because as we know, we all talk about artificial intelligence these days. And those people who are familiar and use and create a lot of things, applications, and improve efficiencies in their world of work through artificial intelligence and coding and robotics are the ones essentially who are going to have an assured future to make sure that they're not replaced by robots or machines, especially because technology is everywhere these days. So I'm going to hand over to Ma'am Poliswa Mahlangu, who's going to take us through this issue of the role of educators in building tomorrow's innovators through coding and robotics. Ma'am Poli, over to you. Thank you.
Thank you so much, sir. It's a pleasure having everybody here for the talk, and for us to have a conversation around what role the educator plays in all of this moving around. So we know coding and robotics from effect from next year in grade R to 3, it's something that's going to be happening. And a lot of teachers are probably asking themselves, am I sufficiently trained? Am I going to be able to do this? Is this something that will work out well? Will I be giving the kids the necessary skills? There's a lot of questions and there's a lot of buzzing. There's a lot of preparing for 2025. And I think this talk will just shed some light on skills that teachers might need to work on and just get ready for the revolution that's happening. So, if you've got a grade R plus and you're sitting with them, we all know that the jobs that they'll be doing have not even been thought of yet. We've been seeing a change in our job landscape. People like data clerks now don't have jobs because you can simply fill in a form and you don't need somebody who's going to be entering data. Telemarketers, I'm sure we've all been bothered by those numbers that just call and you are talking to a robot on the other side. It's jobs that are already moving around. If you want to go travel somewhere, you can do it all online. You don't actually need to go speak to anyone. You can get the same deals online. You go to fast food places now. You're not necessarily met by a cashier at the space. You get in, there's a kiosk where you can select what you want to eat. You can pay right there and you'll have your meal. So jobs are moving. Postal services, if you think of the South African postal services, it's something that's actually non-existent at this point because there's so much transition. Jobs are changing because repetitive tasks are being automated. Technology is replacing stuff, and there's so much online accessibility of things. Just think of you not having your card with you. You're at a loss if you don't have your phone with you because your card is there, your contacts are there, your communication, all of that is happening from just a handheld phone because everything is so accessible from our devices. That's the world we are living in right now, and that's why jobs are changing. And we want to make sure that the kids that are currently in grade R or are going into grade R next year get the best out of it. You know, as Africa, we've been known as consumers of technology, but I think with the introduction of coding and robotics, we are gearing up to be able to be creators of technology and not just consume what other people are feeding us. And if you look into the future and where things are going, data scientists are so much in demand. There's the whole renewable energy movement and the engineers that are going to work in that space. And as much as marketing is moving around, but digital marketing, being an influencer is something that's actually a job. I was actually looking at another course that was being advertised for a university where there is an influencer degree. So millennials can go into varsity and actually learn how to be an influencer. With the other countries, their population is starting to age, so there is a huge emphasis on healthcare work and AI ethics. AI has taken the world by storm, but there's still so many biases in the models. There's still so many things that influence it, and so much fake news that's being easily created with AI. And there's lots of questions around ethics. There's lots of questions around the processes around it. There's lots of questions around the law around it. So there's going to be so many jobs that are also springing up in that space. And we want to be able to give our kids the advantage of having these skills. We want to give our kids the advantage of being able to learn about what makes AI work. So not just use your generative AI, your chat GPTs to create cool looking things, but understand what's behind the process, understand what's driving it, understand how the models work, understand where it's getting its data, just understand that whole space. And that's where we're going. And you might then ask yourself, as a teacher who's been teaching for quite a while, where am I expected to get the skills? Am I expected to have all the answers? Am I expected to be the oracle of knowledge? And how much time is it going to take for me to actually get skilled up to be able to meet all these things? Because there's quite a number of skills that we're talking about. So your role as the educator, I would say, is breeding these innovators. As I said, 65% of children today will work in jobs that we don't know. And you need to be able to give them the necessary skills, give them creative thinking skills, give them computational thinking skills that are going to make them better suited to thrive in that environment that is volatile, in that environment that is uncertain, in an environment where things keep on changing. You need to create students that are adaptable, create students that can just adapt easily to change. And those are skills that are taught in the coding and robotics curriculum. These skills are crucial. Your problem solving, your creativity, your critical thinking, and good for us with the processes of government. It's something that's going to be compulsory in all spaces by 2025. So in grade R to 3, it's something that you will be expected to teach. And I would say it's nothing to be scared of when you look at the curriculum for grade R to 3. It is something that is already being integrated into the curriculum. There's pattern recognition. Kids from as early as grade triple R are already learning patterns. So it's carrying that on just with a focus on it. It's following sequences and having a start, a middle, and an end. Just making sure that the kids are aware of the skills and they're harnessing those skills to make to enable them to be able to code better when they actually get to higher grades. So you might then ask, what are the first steps? Where do I start? It's all overwhelming. I might have gone to one or two introduction sessions, and we were in a room full of 400 people. I went there for the coffee. It was really nice. But where do I actually start when I go back to my school? Where do I actually start when I go back to my space? And my advice would be to start small. So start with your paper-based coding examples. Start with Scratch Junior. Get your kids to experiment and lead the experimentation. Get your students to be the ones that are driving the class and exploring, integrated into existing subjects. One thing that's awesome about robotics is it's where maths and science come alive. I've seen students who never liked or never understood things like friction until they saw it in their robot. Things like angles and how they have an effect on their robot, on how their robot works. Those things, they make the maths just come alive. They make the science come alive. They see the why, because most of the time when they're learning these content subject, sometimes they just don't understand the why. So robotics is an applied space where they can actually experiment and understand the why. So how do we create this environment in our classroom? How do we foster the learning? How do we foster the innovation? How do we also give ourselves enough grace to grow with the students? Because at some point, we are growing with the students. We are learning the code. I remember I was listening to one speaker at a coding robotics colloquial, and they were saying how they actually learned the code with their students. It's something that was thrown at them and they needed to start. And they created a space where the students even knew that teachers also learning. They knew that there's things that teacher doesn't know, and teacher celebrates when you're coming with new information. Teacher celebrates when you are being effective in the classroom. Teacher celebrates when you are the one who's got the solution, and teachers also willing to learn from the students. Fostering a growth mindset, saying I might not be there yet, but it's something that I can do. With the work that we do with a number of the schools, part of our assessment with the teachers before we do training is an attitude assessment. So how do you feel about teaching the subject, and what are your beliefs around it? Because if you don't think you can do it, then you're right. If you think you can do it, you're also right. If you've got a mindset that says this is something that I can learn, this is something that I can grow in, this is something that I'm willing to give myself the space to make some mistakes, but learn as I grow. Provide hands-on learning opportunities, both for the teacher and for the student. It's very easy for us as teachers to just say, I'm going to give the students projects and they're going to work on the projects, but we don't also offer ourselves that grace. You need to experiment. You need to play around with it. You need to be able to take the robots apart so that you understand what makes them function. You need to give yourself that space of hands-on learning opportunities. Give yourself challenges. In a space where you're probably teaching as 3 or 4 teachers, have a tech Tuesday meeting where you guys show off the skills that you have just learned. Partner with a cluster that is interested in professional learning so that you grow with them. And then promote collaborative learning. Collaboration, not just amongst the students, but collaboration with other teachers too. One thing about coding and robotics and project-based learning as a whole, you can't do it on your own. There's so many links, there's so many spaces where you can collaborate, and it's nice to share that load. So promoting that collaborative learning attitude and connecting it to real life world challenges. I often talk back to the first project I ran in around 2016, 2017, when I started at Future Nation Schools, and it was a scratch project for grade 4s. And in that project, they had to create a scratch game. But for it to have meaning, we started looking at what could be the problems that they could solve. And one of the things that they realized is that their little sisters and little brothers that were in grade R or grade 1 were struggling to learn isiZulu and isiTswana. So what they thought they would do is actually create scratch games that teach basic literacy in isiZulu and isiTswana, like counting, like the names of animals, and then the kids could actually interact with those games that they had built. As early as grade 4, those students were given an opportunity to actually work on a product that was serving a real client. The client might have been 5 or 6 or 7, but it was a real client. It was solving a real need, and it gave them so much pride. I remember that exhibition as they were showing off the projects to their parents, and they actually had their little brothers and sisters testing out the games for the first time. It was something that was effective. It was not just, okay, let's get the sprite to move about around the screen. It's going to move 10 blocks and that's what it's going to do. But it was actually coming up with a solution. So making the tech have a good purpose. And if we are looking at our curriculum right now, it is a curriculum that is competency based. And it's quite a move from the draft curriculum, which was still quite knowledge based. But with the curriculum that is in effect right now, it focuses on skills and being competent in skills. So from grade R to grade 9, they're working on the same skills and they're just getting better at it. There's continuous assessment and continuous feedback. You're not just marking a project at the end, but you're giving them time to revise, time to change things, time to improve their solution, which mimics how the real world actually works. In our spaces and our jobs, you don't have a final exam that you just need to cram for, but you've got that continuous feedback, you've got that continuous talking to people to make sure that you are offering the right solution. And there's a whole space for personalized learning. It's quite different in that space. So we could all be going for the same skill, but how we get to the skill might be very different. So there's a lot of room for doing projects quite differently. And this is just an analysis between the knowledge and the competency based. And with knowledge, normally we're just learning about facts, theories, information, definitions. We can all put that all in a nice quiz generator, and students can just get ready for that test. They write the test. And I remember when I was still in high school, people were saying they are doing the CPR, the cram, pass, and forget method. So we don't want students to do that. In the competency space, it focuses on actually building skills and competencies such as critical thinking and collaboration and a lot of other skills. With the knowledge one, sometimes it is quite passive. It's a lecturer, it's the teacher, they are the center of knowledge. They are the ones that just know the truth, and students just need to take that as the truth. In the competency space, there's a lot of demonstrations from the students. There's a lot of interactiveness from the student. It is quite student-centered, and the teacher is more of a facilitator or a coach. And that just requires a different way of thinking, a different set of skills. With the knowledge one, it helps with developing foundational understanding and expertise in the subject. It's quite structured and predictable, which is not the case for competencies. As I said, we can choose to get to a different competency differently, and sometimes that just introduces some unpredictability into the system. But we are training students to go into a world that is very much unpredictable. So it's also giving them that skill to be able to thrive in a world that keeps on changing. And with the knowledge one, we are applying learned knowledge, and sometimes it might be hard to connect it to the real life. In the competency space, you are starting off from the real world and then learning the skill to be able to solve a problem in the real world. So that connection is quite easy. With the knowledge-based one, if it can get outdated, and the content normally doesn't evolve as quickly. Um, I'm sure we've all seen how technology has just changed so quickly, and why the competencies-based space just makes a whole lot more sense, because you are creating a space where kids are learning the skill that's going to solve a problem, but it's not really dependent on the content that's available at that time. It keeps on changing. They can keep abreast with what's happening in the competency space. There's also quite a lot of research, and they are keeping up with the trends that are happening at that time. So these are some of the ways of assessing your competencies based curriculum. So we are looking at performance-based task. I'm going to be testing if your robot does the required things that were listed in the spec. I am looking at your portfolios. So we are building a portfolio, and at some point we will sit and look at where you were in January and how you have progressed through the skill until December. We are looking at a portfolio that is multi-year, because the competencies are also quite multi-year. There's a whole lot of use of rubrics, because we are working with projects. There's also a lot of self and peer assessment. It encourages a reflective mindset where you sit down and say, what were my glows? What were the things that worked really well? How can I improve? Because there's always room to improve. And what have I learned from it? So factoring in that time to be able to just assess and give some feedback. There's a lot of formative assessment, so it's not one big mark at the end. It's not one big exhibition at the end, but we are marking as you go, because you need to be able to see how somebody is improved from a month ago. And there's a lot of milestones. You could have capstone projects. There's reflection and feedback, And one really great skill that I've seen from especially the intermediate phase students that we work with, because there's so many presentations and demonstrations, the confidence that they get to build when they are showing off something that they're proud of. It's a skill that's really going to take them far in life, even if they don't choose to go into a space that's necessarily technological. It's a proper life skill. And then there's also lots of simulations and role play. There's also some really nice platforms where students who might not have physical robots can actually still get to learn about robots and play around with the simulation. Obviously, it's not going to be as nice as actually having the physical robot in the classroom, but it gives all students the opportunity to actually experience the technology. So this is just an indication of the key competencies for the subject. There at the bottom, we've got the 4 key skills that the kids are learning. So it's your problem solving and critical thinking. In every aspect, there's that. There's creativity and innovation. There's also collaboration, working together. And one of the nicest skills that they learn from computing and coding and robotics is the resilience and adaptability. You're almost sure that things won't go right the first time you try. And having that spirit that just says, I am going to try until I get it. I'm going to persist until I get it. It's also a life skill that makes them better suited for the future. With coding, there's 7 competencies. So it's applying computational thinking, it's being able to present a simple coding solution, to interpret and execute commands, to be able to debug, so finding the problems and being able to spot them and fix them, evaluating solutions, so not just saying the code is working, but being able to look at 2 or 3 sets of code and figure out which one's the most effective. Recognizing patterns and creating and completing patterns, which is quite a huge part of foundation phase. Like there's a whole time that's spent on pattern recognition, pattern creation, and just getting their mind ready with that. And then there's also 7 competencies for robotics. With the first one being able to explain what a robot is in simple terms, identifying different types. So identifying from your robot vacuum to your humanoid to your robot dog. So knowing what's there, how it's used, robots in industry, robots for the household, robots in space, robots everywhere, and how they're being used and how they're solving problems and how students can learn from those robots and implement their own solutions. And then there's understanding robots' impact and designing simple solutions and just mimicking a robot and creating and testing and executing instructions. So we know a robot is a robot because it can be programmed and it can follow instructions. So creating those, testing them and executing them. And then there is a digital concepts space where they get to learn about IT and technology, digital citizenship. They are online. They need to be safe online. Learn about the devices and ICT use in the real world, the input processing output cycle, pattern interpretation, creating patterns, and digital skills application. So those are the skills that they are learning in that space. One of the things that the curriculum also looks at is not just the skills, but looking at concepts that the students need to learn and some practices and what perspectives they want them to understand from that. I know my table might be a bit full, but this was just mapping how they all work together. So let's take C3, for example. So in C3, the skill is interpreting and executing written commands. So they are interpreting what the code looks like, and they're executing the code. Things that they need to be learning there. So concepts that they're learning are concepts like operators, your addition, multiplication, division, and how that works, the logic of it, comparison. They're also learning Boolean logic, truth tables, and logical operators. They're learning about event-driven programming and how to handle user interactions. But the practices that they're also learning in that very same competency, how to generalize, how to modularize, and creating computational artifacts, and some of the perspectives that they are getting to work on is questioning. So being able to ask all the right questions, being able to probe further so that you fully understand the question before you go and work on a solution. And perseverance, I think it plays a role as a perspective in most of the skills that are listed because it is quite important. And these would be the robotics competencies also mapped with the practices and the skills. And some of the concepts that are in robotics is just understanding motion, understanding sensors, actuators, understanding instructions and robot logic. Some of the practices that we want the kids to be leaving the curriculum with is design thinking. So knowing that you are designing products for a human. So having that empathy and being able to go and sit and get requirements from an actual human, be able to prototype, keep on fixing the prototype, knowing that you start small and build on bigger. The perspectives that they were also looking at is collaboration. So one of the nicest things about the robotics part, there's a lot of space for group work. So I've spoken to a number of schools, and one of their biggest questions is, okay, this is coming in grade 4. We will be required to get robotics kits. Do we need a kit for every student? And my answer to that would be no. So one of the skills you are teaching them is collaboration. Get them to work in team projects. Get them to understand the friction of everybody wanting to have their say, and sometimes that makes the project not work. Um, some people want to lead, and sometimes they need to be the ones who are designing. They need to understand that there's different roles, and as you are assigning the robotics projects to them, one of the practices that we always say to teachers is rotate the roles. So if somebody was the builder this week, next week can they be the one that's working on code? The other week, can they be the ones that are doing research? The other week, can they be the ones that are doing the final reports? So have groups of 4 that are working together and people learning different skills, because there's different skills from every role. And then the question might be, this curriculum is awesome, but how do I implement it in my classroom? How do I get started? What are the limitations? How do I make sure that they're getting the full benefit out of this? And one of the best ways is to do a project-based learning approach. So categorize your learning for a particular knowledge space into a project. So have a digital concepts project, have a robotics project, focus on process over product. So yes, it's great that their robot finally works, but what was the process? What was the learning as they were going through it? Did they document their learning? Did they fix things? So focus on the process and allow differentiation. It makes marking a bit difficult, but kids just tend to do a whole lot better when they are passionate about the project that they've chosen. So make sure that they still meet the skills, but they can have different options or different ways to express themselves. So here are some of the skills that I think teachers really need when they start moving into teaching in a competency based space. And not just for teachers, because we said as we opened the webinar earlier that we're speaking to educators, and educators might also be parents at home. So instead of being the oracle at home or being the oracle in the classroom, you need to nurture your facilitation and coaching skills. So being able to step back a bit and let the students figure it out and guide them through the process. You need to also have assessment and feedback skills. So what are you assessing? How are you feeding back? What does the final deadline look like? Are they getting chances to revise their solution? As I said, allow for differentiation and personalization, and also be able to be flexible around your curriculum. So know how to plan and design your curriculum so that the skills are still met, even though they're met differently. Mapping and tracking progress. So keeping a portfolio is quite nice, because also when the students look back on it, they can also see the growth that they've experienced. Then there's collaborative skills. So you're not just learning them for you, but also for the students. So you need to be coaching students that are collaborating, but you also need to be collaborating with other teachers. Also skills around student-centered instruction, PBL skills, your digital and technology literacy. So giving yourself the space to grow there, reflective practice, and communication and interpersonal skills. And as we had said, PBL is most of the time the best way to do it. It works really nicely for coding and robotics. There is a clear goal, and then there are skills that they need to learn, and they can always implement those. And then how do you start with implementing? So over and above the skills that you've learned for competency based teaching, learning the skills to question, inquiry skills, project management, because at any given point, you'll be managing over 8 or 9 projects from different classes, resource curation and guidance. The students are going to go to the internet and try find the information. So you need to be able to help them curate the best information. Where is the source? Where is it coming from? Have they asked the questions around authenticity? Is it not just some article that somebody has just generated not so long ago? Is it not fake news? Flexibility and adaptability, and that real world connection and communication skills again. So how are we helping with that? We are currently working on a series of textbooks, and our textbooks are written in a PBL way. So when you are starting term 1 for grade R, and you are working on a pattern recognition project, it starts there asking, so the driving question for this project is, can you find and make patterns in the world around you? And we've put up the 7 A's in a way that students can also just understand them. We would still need the teacher to read this to them, but in this particular project, they're learning about pattern recognition and using their bodies, using objects, using different ways to be able to do their projects. So these are just some of the suggested projects that we have put in the textbook, but it's just some suggestions. Students are free to work on projects that will show off the learning. So could be a dance that they are repeating a certain sequence. They could record that dance and share it with an audience that's away from them. They could be creating a pattern puzzle or telling a story or just making an HR pattern. And one of the ways we're also working with teachers to be able to do this. So over the past 18 months, we've been able to train over 400 teachers, and we want to expand our network of teachers. And we have recently launched the SFISO EdTech Trailblazing Teacher Program, and it works on a tiered process. So all the teachers that we have trained are certified teachers, they've got basic certification, and they've got access to our portal and foundational resources. Teachers can then progress to an advanced innovator as they're implementing projects, submitting their case studies, and they can gain recognition for the great work that they're doing. After some vetting and looking at their projects, we've got the trailblazer level, so the top tier of our program. And this is where they can now mentor others, judge in competitions, have access to exclusive resources that we are trialing, and just help us with the growth. We really believe that creating a community of learning around teachers is something that's important to us, and it helps everyone grow in that space. So part of the program also includes training and certification modules, which we do through our Future Nation College. So there's online courses that our teachers can get through. And so it's courses around coding and robotics, STEAM education, PBL education, training on AI and Internet of Things. And there's also the classroom implementation part. There's so many people who do the training, but don't implement when they get to the classroom. So we're also really interested in what's happening in the classroom. What feedback are you getting from your students? How is it impacting them? And this is mostly some of the ways we recognize. So there's a digital badge for every level, and there's exclusive resources and awards. A speaker that was supposed to be joining me, who is away because he's at another competition, actually won our inaugural Teacher of the Year award. And those are just some of the things that we do offer. These are just a few success stories that we got when the teachers were being nominated for the Teacher of the Year award. So we've got students that were saying they thank Ms. Mabuya Kulu for introducing robotics. It's opened their eyes. They now dream of becoming an engineer. So something that was just playing with robots, because people sometimes think it's playing, but it's changing a student's trajectory because they now really believe that it's something that they can do. Ms. Tapelo was saying to her students that they should go beyond the limit. And this is a phrase that is stuck with them and they're applying it in their life. So not only have they learned the resilience, but it's a skill that they're taking on to other parts of their life. And the students was talking about Mr. Terence and making the classes fun and engaging. Students walked into the class thinking that it was something that was going to be complex, but because of the teacher's patience and innovation, they've made it accessible for all of them. And this one over here, it's just saying the teacher has made coding and robotics actually their favorite subject, and it's something that's going to help them beyond school. So students do see the success of coding and robotics beyond the classroom.
Very much. Thank you very much, Toli, for that amazing presentation. We have a number of questions which have been posted by our attendees. We have attendees both on YouTube as well as on LinkedIn. So, yeah, thank you so much. In fact, you've answered some of the questions that were coming through, especially a little bit earlier. Yeah, so the first question from one of our participants here is, where can we get the unplugged resources? I'll give you like 3 questions at a time to handle, and then question which says, is there an exemplar portfolio available for educators starting to implement coding and robotics to view, where they can gain some insight into the contents of the portfolios and what to include in them. And then the next question is, do you have any small, small classes or sessions for people who've just started introducing coding and robotics? So,
okay,
just those 3 questions for now.
Yeah, I think those are questions that I did try and answer. So the exemplar portfolios, they're included in our training. So we do run training we do have training through Future Nation College. We also run training when we go and implement at schools. And we cover all those assessments. We cover competency-based learning, and we make sure that we equip the teachers with those skills. With unplugged resources, we can also facilitate just getting those into your classroom. So there's quite a lot of unplugged resources, and sometimes it just helps when we have a conversation and see where you're trying to go with your classroom to advise better, and we've got them for sale through Sviso EdTech.
Thank you. And then, the question on assessments, you did deal with the evaluation of impact in your presentation, especially when it comes to competencies. But maybe just on that, I mean, obviously, especially in the public schooling system, the CAPS curriculum sort of identifies areas of assessment. There are a lot of additional competency-based assessments, as you indicated in your presentation. So maybe just your thoughts on that, because often the CAPS, the now gazetted CAPS curriculum, may not cover all the assessments, especially when it comes to competencies. So just your comment on that.
So with the curriculum, it does state what assessments can be done with the competencies, but also in our training course, we also have workshopped some lesson plans and how you would then assess those lesson plans. We do also have summative assessments. So it's not only formative, it's not just in the projects, but there are still ways to actually get students to write a quiz, get them to write the knowledge part of it, because there is a knowledge component. It's not just the skills of it. There is a knowledge component, and in our schools, we've been doing it for quite a while. So it's something that we are improving on what the curriculum already offers.
Okay. And then a question which is about change management, for teachers who are reluctant to adopt this new way of teaching. Any ideas how you deal with change or resistance?
I think change normally works best when it starts from the top. So I'll speak of a number of schools that we have implemented where we've seen most success is where the SMT is where the principal own coding and robotics, is when they make space in the timetable for coding and robotics. It's when they see that it's important. Spaces where we've seen coding and robotics not go so well is where even the management thinks it's something that's an extramural, it's just an added extra. So change really starts from the top. And that's how it can be managed. That's how you can have processes on how we test it out, how we start with a few classes, how we monitor what's happening in the classes, and how we encourage the people who are doing well. Because there are those that will do really well, there are those that will be reluctant. But if you want to start the process, the principals and the SMT need to be really enthusiastic about implementing coding and robotics, and not just for bragging and saying they offer coding and robotics, because also we've seen a number of schools just say that, and when you get into the actual classroom, it's not the case.
Okay. There are questions around the whether the training is free that is being offered.
So training is not free. We do have some free resources on our website. So we've got free robotics mats. We've got some free resources on our Sifiso EdTech website. People can visit and just download those free resources. So there is training that is just minimal that we have there, but most of the training that we offer is a paid for service, but if you look at it comparatively, it's not one of the most expensive. It's something that's quite affordable.
Yeah. I think it's important to say, at the moment, a lot of the training is we try and raise money for teachers to get the training, but that normally goes with, sort of the donor supporting specific teachers. And at the moment, we not, training individuals who may apply for training, but we'll be doing that hopefully from next year. So at the moment, it's groups of teachers that are funded by various organizations to get the training, because obviously the DBE has not, they've done induction, they've done some training, but when you need intensive training and support over a period of time as a teacher, we are able to offer that, but it's paid for by various organizations. But anyway, from next year, we should be able to offer training to individual teachers when you apply to our college, and you can enroll and get the certification that Tolly was talking about. Okay, and then some of the questions have been covered already. Let's see. How do you get access to the platform? So perhaps I don't know if we've posted our website, especially where you can get free resources and so on. Because I think we'll post it on the chat, or for people who are on LinkedIn or YouTube, you will have access to that information.
Yes, but it's on our website, and our website is www.sifisoedtech.com. It's quite easy to remember and get to.
Yeah. And then the slides will be shared with everybody who's attending, but more importantly, these presentation and the slides will be available on our website as well. So you can have access to the slides on our website. Is there any other platform, Tolly? I know we'll post them obviously on LinkedIn.
So they'll be on LinkedIn, YouTube, our website, and people can access them from there.
Yeah, that's correct. yeah, where do you apply for training? You've answered that question. Access training resources, we've answered that question. So I think, let me see, there's a question that just came through now. How will parents be accommodated when it comes to homework or assignments to assist their children?
So with the textbook that we're working on, parents can actually purchase the textbook. This will be a great resource, even if the school that your child is attending is not offering coding and robotics. And with how we've authored the textbooks, it takes you step by step through the projects. So there's activities, there's worksheets for the students to fill in and work on. Even our grade R textbook is quite easy to follow. I was doing some testing on my 4-year-old actually, just to make sure that he can understand the concepts, because you don't want to be creating content that's just too high for the intended user. So parents can always purchase that and actually get to see what's happening in the classroom, and also be able to assist their students with homework. In grade R to 3, which is the one that's being implemented in 2025, parents, you should be able to help with homework. It's not really difficult skills. It's skills that you've already seen in literacy. It's skills that you've seen in comprehension. They've just been tailored for coding and robotics so that they get that mindset starting. So I think parents will be able to help with homework quite effectively. We'll also be working on some resources just to orientate parents around what the curriculum is, and those will be just available for free download on our website.
Okay. And the last question, which kids are CAPS aligned?
So it depends. There's components that students need to be able to work with. From a very simple look at the curriculum in grade 4 to 9, one would easily say microbits and any microbit aligned kit. But if you are working on projects, you can always align whichever kit that you're working with to be able to make sure that you're working with servos, you're working with sensors. As we were saying, there's a lot of flexibility. You just need to make sure that you are meeting the competencies. We do offer microbits in our starter packages. So we've got starter packages on our website that schools can purchase if they're still just testing out the subject in their space. Our starter packages can actually cater for a phase if it's quite small, and you can get started on that journey. Those are microbit backed products. But we do also have some really cool AI enabled controllers that allow students to do a whole lot more.
Okay. A similar follow-up question, which kits are recommended for intermediate phase?
Yes, I think I just answered
Yeah.
that one. And the microbits are always a nice place to start. They've got all the basics. They get everyone started and ready. And if you look at the curriculum and the suggested projects in the curriculum, they do serve it fully. But it's always nice to give students that added extra advantage. So even if you're getting the microbit, even if you're getting our NESA kit, it's always nice to get it with our AI lens and get it with our voice sensor, so that not only can it drive around, but it can see and be able to react to voice commands. When you see grade 5s and grade 6s working on projects where their robots can actually see and they can listen to their voice commands, there's just so much joy in their faces.
Good. That really concludes our questions and answers. So let me take this opportunity to thank all of our attendees for attending this webinar. Hopefully you learned a lot from it. And as we indicated, all the presentation or the slides are going to be on our platforms, so you can access those. And for people who may have missed attending this webinar, you can just direct them to our website. We should have the presentation up on our website. If it's not up already, it will be up by tomorrow. So thank you. We really appreciate it. And thank you, Memtoli, for an amazing presentation as always. Yeah, and I also just want to thank our hosts, our marketing team, AI, marketing and media, and thanks for attending, for spending this time with us. Appreciate it, and good night.
Thank you so much. Good night.